All right, so let's see. Let me go ahead. What is this? Got it working. PHY 222. And we are going to be talking about mirrors. And I think if I'm not mistaken, it's chapter 23, if I'm not mistaken, in your book. All right, what's today's date? 23, 26. All right, so let's see. Last time, let's see if remember what we talked about. We talked about what? Mirrors? Now, how many types of mirrors do we have?
Concave,
Epic,
convex, and flat.
concave, convex. And basically, your concave, this is going to be your dull. It's like a cave. The shiny side is on the inside, so it's like a cave. Concave like a cave. Your ray goes in and it reflects back. On the convex, it is the opposite. So this is going to be your dull side, and your ray will reflect off the shiny side. Are we with me so far?
Yeah.
And when we talked about it, we said like for convex mirror. Oh, that is horrible. Okay, I'll take that because I'm just going to use an example. You got in the middle of the mirror, that's going to be uh your principal axis that we talked about last time. In the middle over here, there's going to be your pole. We give it a little p. Somewhere in there, we get f for focus, where the distance from the pole to f, there's going to be your focal length. And you'll see, oh, I don't even like the word the length came out. That's your center of curvature, like we talked about last time. And in a convex mirror, so basically this side is your dull side. Your rays, let me get a different color. Your rays comes in, and because of the normal, it goes in. I guess here's your normal axis, and it goes in to the focus. And I'm not gonna draw drew this like last time, so I just wanted to remind everybody of that stuff, right? So when you talk about the focus, it's oops, the point, the rays of light is focused on a single point. Now, the one that's going in here, that's going to be what your incident ray, and basically will reflect back. I guess it'll reflect back this way. Well, actually, let me just draw the normal line better. me get a different color. Green. I don't know why I'm not using green. That's your normal line. Principal axes. Actually, I'm doing it backwards. That's better. Where you got your both angles going in. And that goes in there through the focus, which is the point in the rays of light is focused at a single point. Uh, Everybody with me so far? And when we talked about the focal length, distance from pole to the focus. Everybody with me so far? Where your F is going to equal to R over 2. And R, that's your radius of curvature of your mirror. Okay. Everybody with me so far? Awesome, awesome. Okay. So the first thing let me talk about is your concave mirror in a little bit. Let me just talk about it a little bit. So if you guys, here's your mirror. This is going to be a principal axis right over here. Actually, I can't write it. I can do it with that. Okay, I'll pick it. Again, so this is going to be your concave mirror. So this is going to be your dull side. Here's your shiny side. Here's your pulpy, and I'm going to get a different color. All right. Let's say here's your focus. And let's say this is the center curvature right over here. I'm just going to exaggerate a little bit. All right. Now let's say you're placing an object in front of the mirror. So this object is, let's say, it's right over here. And let me get it green. All right. So what's going to happen? You're going to light a shine and line on the object. You all with me so far? And this object is going to hit the shiny side, which is this is again bad. I'm going to try to do it. Yep, I'll take it. I don't. Okay, that's better. And it's going to reflect through the focus. Now, the question is where the image is going to be. So basically, to figure where the image will be, we're going to pick a point on the object. So let's say point one, which is right over here. So I'm going to give this This is your point one object. This line in from the top. Now this one goes what? Parallel, and we said it's going to go through the focus. The incident ray will go parallel to the principal axis and through the focus after reflection. Okay. Let me get this color. All right. Now, also we go onto the pole, which I did just a great job with this. Yep, got it. And it will reflect back from the pole at the same angle. I just had it right and I just did not extend it. I'll just do it like that. Where again, you get your both angles over here. You take the R and take that. Are you with me so far? Everybody with me? Okay. So let me go ahead and just write it down. Now, when the ray goes from the object to the pole, it reflects on the same angle. You with me so far? Okay. And same thing. I mean, you can say also from the object to the focus, it will go parallel. Let me say ray. Ray from object to focus. Sorry, not from, yeah, ray from focus to object because we did the object from focus. The ray from, yeah, that's correct. Your object to your focus. Reflect back parallel. And this is the one that's happening over here. You all see that? All right.
Can you go back to what happens when the ray goes from the object to the pole? Thank you. Okay, I'm good.
All right. So basically, we have two of them, right? We have going, and this is actually a little bit again. It's supposed to be, if you go in, you, it goes in to the focus, back parallel. Now, again, you got two of them. Are you all with me so far? One going through the focus and one going through the pole. You all with me so far? So I'm just gonna, instead of having to do a bunch of lines, I'm just gonna eliminate the last one just to make it easier. And it's gonna go through through it reflect back through the focus or through the pole because it goes back the focus back parallel is just inverted. Does that make sense? Are you with me so far? Instead of having so many
Yeah.
lines. Okay. I just wanted to write that down. So now we have the object. Once we put the object in, that we said it goes parallel through the focus or focus parallel or through the pole, come back with a same uh with the same angle. We get an image formed between F and C, your focus and your center of curvature. This image is gonna be a real image. What does that mean? That means if I put a screen on there, if I put a screen on there, you will see this image on the screen. Are you with me so far? Now, so let me go ahead and write this down. So the image between F and C is going to be what? If you notice, it's inverted upside down. Now, why is it inverted? It's inverted because, actually, let me get a different color. No. Why is it inverted? It's inverted because it's a real image. Yeah, read it again. Again. It's just I'm running out of room. Now, what do you mean? What did we mean when we said we're a real image? That means can capture on a screen. Very with me so far?
Yeah.
And if you notice, this is actually where is it? Okay. So basically, and that's what you're actually looking at. So if you're actually looking at it, so your eye would be like, you know what? I'm gonna give you green eyes. It looks creepy. Looks like from the guy from The Simpsons, whatever, the Martians, whatever. Actually, let me do this. This is your eye, and this is what you're looking at, right? Are we with me so far?
Mhm.
Now, the thing is, this object is far away, and you're getting an inverted picture over there. Um, Now, what happens if you move this object? So if you take this object, what happened? Now, let's say you take this object, and let's say you move this object closer. So when moving an object closer, what's going to happen to the image? You're going to notice if the object is right over here, and I'll just draw it. So these are my principal axes right over here. This is my pole B. This is F. This is C. And let's say my object is right over here. No, let me get it closer, actually. Let me get the object closer. So if you get the object over here, what's going to happen? It's going to go, we said it's going to go through the focus or through the pole. Mm, ah, I don't know why I drew it so small. Okay, I'll take it. You know what? I'm just going to draw the whole thing better again, a little bigger. This is too small. Let's say your object is right over here. This object is going to go with the ray, and so we go down. Or we're going to go through the pole, coming back. So you're going to notice you're going to have a bigger image than the first one. Notice when the object was far away, your image was smaller. The closer it gets, when you move an object closer and closer, it gets bigger. Closer to what? Closer to its center of curvature, which is your C. When you're moving the object closer and closer to the center of the curvature, the image gets bigger and bigger. You all with me so far? So basically, your height of the object is going to be still bigger than the image. Sorry, the height of the image. I'll call it HI or HMG, whatever you want to call it. So be HEIGHT of your image. But then the height of the image gets bigger and bigger. That's when you get closer to the center of curvature. Y'all with me so far? Go, go. All right. Now, what is now? What happens with, let's say, when moving, and let me go ahead. I didn't label these. Let me go ahead and label these before I forget. This is gonna be your image, and this is gonna be your object. And this is gonna go this way, and this is gonna come this way. Let's turn around. Okay. So when moving an object to the center of curvature to C, or not to C, at C. So basically, let me draw it again. So here's my principal axis. Let's say here's my focus, here's my center, and we got the object going in at the center of curvature. Well, okay, so you're gonna have basically what we said. We get two rays. One that's going through the focus, one going through the pole. So this one goes through the pole, and one day I'm gonna know how to draw a straight line. It's coming in where the angles again it does not look like it over here, but oh no. Try one more time. Try one more time. I'll say these angles are equal to each other. And then you got, we said, is gonna go in through the mirror. Maybe let me actually put this so you know which one's the dull side, which one's the shiny side. Goes in, and it should pass through the focus. And what you notice, if I was a good uh, okay, I'll take it. So when you move an object to the center of curvature, you're gonna have the exact same image inverted. So the image height will be exactly as the object height. So your h of the object is going to equal h of the image. Are you all with me so far? Okay, now let's say we move the object beyond C. So let's say, okay, when moving the object between F and C. So again, let me draw it a little bit bigger this time. Here's my mirror. Again, here's my pole. Here's my F. Here's my C. And let's say this time my object, I'm placing it over here. Let me go ahead and say this is the dull side. So what's going to happen? You're going to have a light ray going in. Let me get a different color. Again, parallel through the focus. And we said it's going to go. Let me go ahead and label these. What color? Green? Let me try to get the same angle. Yeah, that's better. Again, I'm trying to get the both angles to be like really steep. And what you notice is you're gonna get a image on here. Again, inverted because it's a real image. Now, your height of the image will be bigger than the height of the object. Not like this sounds. Now, so let me go ahead and write this down. So basically, the closer you bring the image, not the image, the object. The closer you bring the object to the focus, the fast, not faster, the further. The further the image will be. Now the image will get bigger. Okay? So the image will be bigger and bigger. It will start getting a little faded and faded. So this is your image, and this is your object. Everybody with me so far? Any questions? Awesome. Now, let's say when moving the object at the focus. So here's our little thing. Whoop. I don't like it. Still don't like it. So here's the principal line. Again, this is my principal axis. Here's my P. Here's my focus. And here's my center of curvature. And we said that we put the object on there. So basically, your incident ray, again, we said it's going to go through the mirror. Let me go ahead and put this. Because we're dealing with, yeah, I wrote a concave mirror. Okay, I did. So again, this is all concave mirror. It's going to go through the line and through the focus, or we said we're going to go through the pole, going on down. Again, here's your angles. Now, basically what's going to happen, again, we said there's two rays, your focus ray and your pole ray. Are you all with me so far? On the first one, your pole ray, sorry, your focus ray. Let me actually write this down. This is your focus ray because it goes through the focus. Parallel focus, focus parallel, right? Your focus ray goes in to the focus. And the second one is your parallel, no, not parallel, sorry, pole. Pole ray. So you got two rays that control this. The pole ray and your focus ray. You all with me so far? And each one you goes in is gonna form the image where they both meet. So again, this is your focus ray. This is your focus ray, and your pole ray. Again, they meet over here. That's where you get the image. Same thing. Your focus ray, and you get your pole ray. And where they meet up, that's where we got the image formed. And okay, the image is gonna be a little late. Let's do okay. Now, in this case, you get your image ray, and your focus is gonna go rather than that. So this is gonna be your focus ray and your image ray. Oh, not sorry, pole. Yeah. All right. So have you with me so far? Two rays, your pole ray and your focus ray. You all with me? Now, in this case, what's gonna happen? They don't meet. If these two lines don't meet, you get no image. So basically, after, oh, not after, in this case, the two rays, which is going to be what? Your focus and your pole, become parallel to each other. That means they will not meet each other. Are you with me?
This happens at the focus.
Yeah, when you're at the focus, exactly. Okay? The two rays, the focus and the pole, become parallel to each other. That means they will not meet. When you say they will not meet each other, that means there is no image. Okay. Now, some might say it's formed at infinity. Are you with me so far? Ted, are you with me? All right. So we got the object, okay, beyond the center of curvature, on the center of curvature, at, between them, at F. Okay, now let's say, uh, when moving an object to, or not to, let's say between the pole and the focus. So let's say here is my little thingy, and it's coming in here. Here's my pole. Here's my focus. Here's my center of curvature. And listen, my object is right over here. Now, what's gonna happen? Well, first of all, here's my object. There's the object over here. I did. Okay, here's my object. All right, so let's see what's gonna happen. So again, two rays, one going through the focus parallel, one going to the pole back. You all with me so far? So your object one, you're gonna go to the pole and back. Here's your angles. Your object two, okay, we're gonna say it's gonna go in here. Now it's gonna go back to this way, but we said it's gonna go to the focus. So here's your focus. And it's gonna be, again, this is a horrible way of me being a line, and I'm very sorry. There's no way to do this on the software. Huh. Okay. Let me extend this one also. This one extends. Let's say over here. And that's where you're getting your image. Now, actually, hold up. Let me control my dot. It's going to go through the focus, not going to meet. Now, here's the thing, because they're not meeting, it's coming in closer. Your image, so your eye is going to be right over here. Let's say this is your eye. Okay. Now, the image is not going to show up over there, but what is going to happen, and again, this is your dull side. A new image would form. This image would be bigger and it's formed because of your reflection. Okay. So the image is appearing where? You're looking at it in the mirror and it's showing up, it's behind the mirror, but it's not over there because remember when we talked about real and virtual images? The image is not technically there. So basically, what you are getting at this point between P and F is your object. And at this point, mm, let me try orange. I never tried orange. At this point, you are getting an image. What kind of image? A virtual image. Not only a virtual image, it's a big virtual image. Basically, it's magnified and it's not inverted. Okay, anybody can give me an example? Anybody ever popped a pimple or did the makeup or in a makeup mirror, right? Uh, or took like an unwanted hair with tweezers, for instance. You know, those types of mirrors that you go in, it makes your face bigger. That's because the object, your face that you're trying to look through the ray, is between the focus and the pole. And the closer you get, the bigger the object gets. Are you all with me so far? Everybody with me? Yes, no, y'all quiet today. Okay. For instance, pimple mirror. I will call pimple mirror or makeup mirror. Makeup. Or you've seen them also in shaving mirrors. Now, basically, so you are looking over there. There's not going to be an inverted image. There's not going to be a real image. There's going to be an object over there. This object is a virtual image. That means because it's a virtual image, that means there is no screen because it's a virtual image. There's no screen next for it. So basically, let me just go ahead and get a black. Uh, for concave mirrors that we just talked about, as long as the object is inside the principal bill, principal focus, the image is real. Inside the focus, the image is virtual. The closer the object to the principal focus, the bigger it gets. Everybody understand everything about concave mirrors? What's the next one going to be? It's going to be what? Anybody knows?
Convex.
Convex.
Convex mirror, which basically, again, in your convex mirror, it is the opposite of the concave, which means that this is going to be, again, your dull side, and this is going to be your shiny. side over here. And because the shiny, so basically your object will be outside the shiny area. And in this case, again, you have two of them, right? You got an array. This is your object. You get array going in, which again, according to the principal axis, because it's moving, it reflects at a certain angle. Okay. And oh, I forgot to focus. So basically, here's your eye. So your focus would be like right over here. It would look like it's inside. And it's basically an extension. Actually, let me actually move this. That's better. That's your focus. And we said also it goes through the focus. Here's my pole. We're gonna go to the pole, which means it reflects back at angle theta I, theta F, which extend this one, the reflection angle back. And what do you have? You have your image. Everybody with me so far? Awesome, awesome. All right. So, so basically, for concave mirrors, your rays, your incident ray will go from top of the object. Let's see, we went from the top of the object. And again, I'm not drawing like a whole bunch of lines. Y'all with me so far? But it's basically two of them. Going to the focus or through the pole. You can go focus at any angle, but this is going to go from top of the object parallel to the principal axis. And now here's the thing. Your focus is inside. So basically your ray, your reflected ray, actually means right on the reflected ray, will not go through the focus. If ref, if reflected. But it appears as if the or not the as if the focus or not the focus. So the reflected ray will not go through the focus if reflected, but it appears as if it does, if it's emerging, if it's emerging. I'll say it's emerging from the focus. So the reflected ray will not go through the focus if reflected, because again, it's the focus inside, but it's gonna appear as if it was going in through the focus. Okay. Um, Now from the object to the pole, the two rays, your incidental and your reflected, diverges from each other, which means, actually, let me put the word diverges from over here. I want to use it. And when you say it diverges from each other, that means, again, you're looking at the image inside the mirror. Does that make sense? So if it diverges from each other, that means you get no real image. So really what you are getting is a virtual image. So basically, from the object to the pole, the two rays diverge from each other. That means you get no real image. But what you get is virtual image. Basically, it's gonna be actually let me basically get a virtual image. It's gonna be smaller in size and it's located between the pole and the focus. And that's exactly what we got over here. Basically, because it's a smaller image, means you can fit more images on the mirror. Anybody knows what type of mirror we're talking about? Anybody seen gas station mirrors? Right? Or convenience stores? You with me so far? Or parking and parking lots, parking garages, parking mirrors. Gas station mirrors, parking mirrors, etc. It will actually show you bigger area. The image will be small, but you see the bigger area. Are you with me so far? So let's say, for example, Let's say we got this type of mirror. You got this line over here, the principal axis. Okay, here's your focus. Here's center curvature. And let's say you are having a ray of light going in this way, which I don't know why I didn't go through the focus. Okay. Everybody draw this? Tell me yes or no. Everybody draw this? Okay. Draw the reflected ray. So this is the incident ray. Draw reflected ray. All right. So if your reflected incident ray is going over here, that means your reflected ray will be, it goes through the focus parallel. So this is going to be your reflected ray. Now, what type of mirror is this? What type of mirror is
Okay.
this? Concave, right? So basically, rays on a concave mirror through F reflect parallel to your principal axis, which that's what that is. Again, that's your pole. That's your focus. All right, you all with me so far? Awesome. Awesome. All right, well, let's do another one, shall we? Let's say, what that, example one? Let me just call this example two. So let's say you got a mirror like this, and I can do a better mirror than that. Here's your P, here's your F. Let's see your C. Now, I didn't tell you all about this. I was waiting actually to put this question. Now, let's say you got a light, incident ray, going in. What color? Give me a color. Green. In here. What's going to happen? That's your incident ray. And I'm going to say in here, draw the reflected ray. So where's it going to go? Anybody knows? So this is going to go in. It's going to go in all the way to the center of curvature and going in on exactly the same path. Now, again, what type of mirror this is going to be? What, a convex mirror. So because it's a convex mirror, you raise to the center of curvature C, reflect back at the exact opposite direction. Okay, well, let's say here, let's do another example, shall we? Let's say, okay, let's say it doesn't go through the C. Let's say you got this over here, along with your principal axis. Here's your P, here's your F, here's your C. Example three. All right, now let's say it goes in through there. So let me get a color. Here's a color. So let's say, yeah, I should go ahead and just edit. That's it. Okay. So this one goes in. Okay, that's better. So what's going to happen in this case? Okay, so this is your shiny side, this is your dull side. That means this is going to reflect back parallel, but it has to go through the focus. So it goes in through the focus, reflecting parallel. So your reflection would be over here. So this is going to be, let me draw this in a different color. So basically, this is gone. Vex. Forget to write the question. Draw. Uh, so your reflected line will be going back again, parallel. So your this is gonna be a convex mirror. Incident ray. Reflect. Well, not reflect. Toward F. Toward the focus. Reflect. Back. Parallel to the principal axis. Okay. Okay, let's do one more example. Let's do one more example, guys. And this is the example four. So here's our mirror this time. So let's say here's our dull side. Here's our, that's an ugly line. Here's P, here's F, here's C. So let's say you get a, again, let me use a draw the reflected ray. So let's say you got a reflected ray, incident ray going this way. Now notice when I put the incident ray, it's going towards the mirror. Does that make sense? Are y'all with me so far? Are you all with me? That's important to understand. When you have incident ray, it goes towards the mirror, right? If you have a reflector, it goes away from the mirror, right? So let's say if you have it in there, where's it going? So basically, it will
Towards the
go
focus?
exactly. It will go. No, I did not mean to do that. Yes. Through the focus. So basically, your convex incident ray parallel to principal axis reflect back through your focus after reflection. You all with me so far?
I thought that was concave.
My bad. At least one person is paying attention. Well, that's good. That means everybody is with me so far. Everybody with me so far? Now, so right now we talked about convex mirrors and concave mirrors and the incident rays and the reflected rays going in through the focus, curvature, and the pole, and the images where it's formed and all that. All right. Now I want to talk something about called sign conversion or sign convention. How about convention? Per convention, which basically it's what I'm going to introduce to you. It's the rules to apply positive, positive, yes, and negative signs to measurements. So we're going to talk about right now sign convention, which is basically the rules. I'm going to introduce three rules on how to apply the positive and negative signs to measurements. Okay? And let me go ahead and write them over here. Here is my rules. Actually, hold up. My I'm trying to figure out a cool name. I can't, but okay. My three sign rules. Mirror sign rules. And you know what? I'm going to take mine and we're going to call Dr. Malik. Okay. Rule number one. All You know what? Can you just put this up higher a little bit? I'm gonna need all the. It's gonna. You know what? Dr. Mac, three sign rules. Three. Actually, mirror. All right. So this is gonna be my three rules that you're gonna follow when you actually assign signs when we actually work with problems right now. Okay, so we talked about images, we talked about the distances, we talked about where they're at. Now we talked about the signs. Now, the first sign, the first rule is all distances are measured from the pole. Are you all with me so far? Everybody with me? All the distances are measured from the pole. What does that mean? Okay, now how many distances we actually talked about? We talked about three distances. So when we talk about all distances, we're really talking about there are three distances. A is how far is the focus, which is basically your focal length. The second one is how far is the object distance. And the third one is how far, anybody knows, is the image distance. Those are the three distances that we actually use to measure the pole. Now, we talked about pole. I mean, I've been saying pole, 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 pole the whole time. What's a pole? When you talk about pole, you're talking about the center of the mirror. And you know what? Let me actually go ahead and write this down at the beginning also. When you think about pole, you're talking about the center of the mirror. So every time I talk about pole, I'm talking about the center of the mirror. And that's where we take the distances from, is to the center of the mirror. Everybody with me so far? Okay, now rule number two. These distances, the three distances that we talked about, can be measured either in front of the mirror or behind. And what do I mean by that? So basically, let's say you got a mirror, you got this side over here, let's say it's a concave. You got an object. Let me move the object a little closer. Here's your object. Here's your image. So basically, you got a distance over here to the pole. This distance, this what? Distance of the object. And you got from here to here, distance of the image. Let's say my focus over here, which is going to be your F for your focal length. Or you might have it this way, where this is your dull side. Might have your object. If you look at it, probably like something like right over here, where you have this is P. This is the distance of the image. This is the image. And this is the distance for the object. And let's say I'm going to say my focus is right over here. Focus. So these distances can be measured either in front of the mirror or behind the mirror. It depends on the mirror. Does that make sense, guys? Okay. Uh, Now we use the second rule to figure out which distance we call positive. Remember, that's rule number one. We have three distances. Your focus, your how far away the object is, and how far is the image is. Now, these distances can be measured in front and either from front or behind the mirror. Depends on the mirror. Now we use the second rule to figure out which distance we call positive. Now the images can be formed in front of the mirror and can be formed behind the mirror, kind of like what I just drew right now. It can be formed in front or it can be formed behind the mirror. Now, here's the deal. To differentiate differentiate. I hope I spelled it correctly. Differentiate. Did I spell it correctly? I think so.
Looks right.
Differentiate. To differentiate between the two distances, we are gonna call one. Kind of like, remember Franklin? What did he call the two charges? What did he call the two charges?
Positive, negative?
So we're gonna call them positive and negative too. Might as well. So we call one positive and the other is negative. Now, now here's the deal. But which which is negative or positive? So here's the deal, right? So you got the difference between the two sides. We're gonna call them one positive, negative. But which one is positive? Which one is negative? And it all depends on the incident ray direction. And what do I mean by incident ray direction? It means it's always positive on the same direction as the incident ray. Okay, what does that mean? All right. Well, let's say here's my mirror. And I don't like this mirror. The mirror, but I can draw one better than that. Okay, let's say there's a mirror. Here's my principal axis. Here's my normal line, principal axis. Here's my P. Here's my F. Okay. And I got an object over here, right? And the incident ray is going in this way. By the way, let me just, here's my dull shot side, that way you know what dull side is. Okay, so the incident ray is going this way. Because it's going towards the right, okay, this side would be positive and this side would be negative. So because it's going to the right, the right side of the pole, he is positive, and the left side of the pole is negative. I mean, think about it. You go, shoo. That's like an axis. Does that make sense? Are you with me so far? All right. Everybody with me so far? Okay, so basically your incident ray direction is always positive. The direction it goes. So for instance, let's say I don't know, let's say this is my mirror. Let's say this is my P, my pole. Let's say this is F. And let's say my object is over here. Here is, let's say, the distance for the object. We said, well, hold up. Let me put the image first. I didn't put the image. Hey, let's say the image is over here. I don't know why I'm cutting myself short. Yeah, that's better. So let's say, let me get this for the image. Let's see your image over here. So let's say the distance. We got three distances, we said, right? What are they? The first one, you got the distance of the object from the pole. So here's your pole. The distance to the pole is, let's say, 3.5 centimeters. The distance to the focal point is 2 centimeters. And let's say the distance to this little fellow over here, to the image, let's say 5 centimeters. Now, your object is on the negative side. So, oh, I'm sorry, hold up. I forgot to put one more thing on this one. Here's your incident ray. So your object, because the incident ray is going in this way, that means it's going in. That means this is gonna go through the P. That means here's your positive, and this is gonna be your negative side. So it means the objects of the negative side, because the incident ray is going in. So the object distance is negative, and it's gonna equal to what? It's gonna have to be minus 3.5 centimeters. That means this 3.5 will be negative because it's on the opposite side of P where the incident ray goes in. Your focal length is also going to be on what? On the negative side. So the F distance is negative and is going to equal to minus 2 centimeters. Now, so we got your object, you got your focal length. The third one is your image distance. Your image distance is on the negative side because then again, then the ray is going through the pole to the opposite side. So it will be negative, which is going to equal to minus 5 centimeters. So this is really going to be minus 5. Are you all with me so far? Okay. Let's do another example, shall we? So let's say here is my mirror. Awesome, awesome. All right.
Mhm.
So let's say we got a mirror this time. And here's my principal axis. And let's say that here's my object. I'm sorry, I made that. Wrong ones. Let's do the opposite side. So this make this one dull. And here's my object. Here's my pole. Here's my focus. Let's say the focus is 2 centimeters. My object distance from the pole is 1 centimeters, and let's say my image is forms over here, and this is the image, and this is gonna be, let's say, 7 centimeters. And let's say, because here's the shiny. Oh, I'm sorry. I flipped them over, didn't I? This is the image. This is the object because I'm looking. Here's my dull side. How am I getting like an image from the dull side? So here's my object, and you're getting incident ray lighting up this way. So you get an incident ray lighting up this way. Your object, your image seems inside the mirror. It's right over here. It's a virtual image, and it's 7 centimeters. Now, this time, that's your incident ray. So this time, our incident ray is going to the left. So the right side this time of the pole P is negative, and the left and the left side is positive. So basically, because it's going in here, here's your pole, that means this side is going to be positive. This side is going to be my negative. So basically, your object distance at this point, it'd be what? Um, is going in there. So this would be what? Negative 7 centimeter. The distance of F, your focal length, is inside. Yeah, here it is, 2 centimeters. So it'd be, say, my focal length, that's going to be inside to be still 2 centimeters because it's in the positive side. And let me get back to black. My distance of the image, in this case, it'd be -1. Sorry, not minus. It's in the positive side, be 1 centimeter. Everybody understand rule number one, rule number two? Okay. Rule number one, you get three distances: your focal length, your image, and your object. Number two, wherever it's going to go in, that's where incident ray, that's where you sign up for positive and negative. And again, it'd be like, having a Actually, let me take this away from here and put it over here. A Cartesian. Does that make sense? That brings me back into rule number 3. Now, it says if it's if object or image is up the or principal axis, then it is positive. If the object or image is below the principal axis, it is negative. This one negative, right? Negative.
Yeah.
Awesome. So basically, what does that mean? So if we actually go back to our picture that we just did, our example for 1 and example 2, okay, that means here's our inverted picture, and I'm going to put this in green. That means it is positive. Our image inverted, whichever image it is going to be negative. For this one, it's going to be positive, where this one is positive, which means it's the direction that you cannot see the picture. Does that make sense? Does that make sense, everyone? So basically, it's two things. Okay? You got 3 distances. 1, your focus. 2, your object. 3 is your image. And from those, the incident ray direction is positive. And if the image is up, it is positive. Okay, with those 3 signs. And really, this is going to be called a Cartesian it's called a Cartesian sign. And if it's basically sounds familiar, because basically it is going to be your graph, which is labeled as usually positive and negative. It just depends on the incident ray. That's where you get Cartesian. Does that make sense to everyone? Okay. And what I'm going to do, I'm going to stop over here for today. Everybody good with that?